My name is Ryan Krawczyk. I'm a lead developer with the financial services group at InterSystems. And today I'll be presenting on the assistance feature of our core product at Financial Services, which is InterSystems Data Studio, or IDS. In terms of a roadmap, after introductions, I'll give a quick architectural breakdown of Data Studio. Then I'll describe a little bit about our AI story and how we arrived at the agentic system we have today. After that, I'll describe how coupling together that IDS platform with AI assistance proves to be a very robust product. Then I'll do a quick demo of IDS. We'll dive in and explore some industry use cases as well, before finally wrapping up with a conclusion and, of course, answering any questions you have. So first things first, I'm going to do a quick overview of our core product, InterSystems Data Studio at Financial Services. In financial services and in other industries and verticals as well, it's a very common problem to have your data spread out in all of these disparate, different sources across your data ecosystem. So you might have CRM data in a Salesforce instance, files in an SFTP server, SQL tables in an Oracle SQL server, objects in an S3 bucket. The list can go on and on. It's really difficult to make sense of all this data when it's spread out and in a sparse format like this. It's difficult to derive meaning from it and to get that overarching picture and allow it to drive your day-to-day and your long-term business decisions. IDS solves that. So it's a data orchestration and integration platform. You can take all of these external sources and you can register them and connect to them with IDS via the data catalog functionality. You can learn about the shape and the schema of this data, things like primary keys and data types, if that applies to your data source. And then you can set up pipelines to bring the data into IDS, apply different transformation and validation rules to make sure the data is legitimized. And then once you have that golden data in the form that you want, you can promote it to other data models or even externally to other sources. Once it's all here in this unified data layer, you can do things like hook in your business intelligence and your data visualization tools like Tableau and AtScale, or you can even build cubes and perform analytics. And this is all well and fine for someone who's a database administrator, right? Because they understand the shape of the data and the schema of the database, and they can effectively write queries against this data or build cubes to learn about it. But that's not our only user class. You might have a business user who comes along and they want to write a report and do an analysis, something like that. They don't have inside knowledge of the database. They're not writing queries or building cubes, but they are showing up with natural language questions and they're looking to get meaning out of the data. That's where AI is going to step in. And I'll start off by describing a more rudimentary system for simple RAG, or retrieval augmented generation, and a single LLM, large language model. You can see here that the LLM is going to have access to a vector database. This vector database will contain text data that will enable the LLM to supplement the answers with text based on searches against that vector database to determine what text in there is relevant to the question. Just as a quick description of vectors, it's going to be a mathematical representation of the text data so we can map it in the semantic space. That way you can apply your semantic similarity algorithms like cosine similarity. All right, anyways, the user's question is going to come in, right? And it'll be something like this. What was the quarterly revenue of Apple for the years 2023 to 2025? Plot the results on a line chart. So the LLM is going to be instructed to take this input and try to break it down into a series of keywords. Things like Apple, quarterly revenue, the years 2023 and 2025. And we're hoping that in this one shot, it applies the keywords, performs the semantic similarity search, and gets all of the necessary vectors back from the database. So just to keep in mind, that's all vectors related to revenue, all vectors related to Apple, and it needs to hit for all 12 fiscal quarters between 2023 and 2025. Once it has those relevant vectors, this LLM needs to take the input as well as the vectors returned from the database and any of our prompting and instructions. And with all of that context, it needs to form a complete and comprehensive answer for the user. So the question is, does this LLM always account for everything given the context? Will it produce reliable answers for us? We've often found that the answer is no. That for this amount of context, it's often the case that LLM will deprioritize certain instructions. It might have some misses on the vector search, or it might forget to respond to certain aspects of the user's input. So from here, we graduated to a multi-agent system that can perform agentic RAG instead of simple RAG. The way this works is instead of having a single LLM, you have a network of LLM agents. All of them are responsible for accomplishing different tasks. And since they're only concerned about a singular specialized task, they receive less context per agent to do the job that is required of them. With less context, the agent is able to do a more focused job on only a certain part of the puzzle, from there producing a higher quality result. So here comes the Apple revenue question. It will go to our supervisor first. The supervisor is going to take this question and break it down into a series of tasks, right? So the first 3 tasks are all vector searches related to Apple for the individual years, 2023 to 2025. And then there's a 4th subsequent task to graph the revenue data. The supervisor will delegate those first 3 tasks to our vector search agents. So these vector search agents are aware that the vector database exists, and their sole job is to take the search parameters, run a search against the vector database, applying cosine similarity or what have you, take the results that are returned and give it back to the supervisor. More vector search agents or less than this can be spun up depending on the nature of the search as well. But the nice thing here is that these 3 searches can be parallelized because one doesn't depend on the other. So the vector search agents will get this search with a more refined scope, produce more reliable results because it has more strict search parameters, and it will return all of this data to the supervisor. From there, the 4th task is delegated, which is to create the graph. The graphing agent you see here, it doesn't know the vector database exists. It doesn't care about the vector database. All it does is it takes data and it graphs it. Just performs one singular job, and after that produces the graph. That's all it focuses on. Supervisor will take all of this data that was created, give it to the combinator, where we will nicely format it and mark it down to be produced for the user. So let's take this same agentic system here and plug it into our previous scenario. The Apple revenue question comes, and now we have an agentic system that can do a subdivided and organized search with specialized agents against the vector database, running multiple searches with a more refined scope to give us better and more guaranteed results from the vector search. From there, if the user's question has other aspects to address, like graphing, we have dedicated agents for that that are solely responsible for making a graph. From there, we'll consolidate all of that data together into a more complete, more comprehensive answer for the user. What I've talked about so far is the IDS platform and how it acts as a data orchestrator, and also the power of an agentic system. But next I want to touch on how pairing these 2 technologies together can create a very robust and a very powerful product. The scenario you see here is actually one I'll be showing in the demo later as well. So this is a user coming along and asking, are current geopolitical events reflected by our macroeconomic SQL data? They might have access to a certain number of sources, like some investment research reports on file, economic and financial data on a SQL server, or a New York Times subscription. And how the story used to go would be they just do manual research to get their answers. So they would look through all of this data, parse through it, determine what data is relevant, extract their key findings, and compile it in a report. Very tedious, very time consuming. Well, IDS says no more, because with IDS, you can register all this data, unify the data from all these sources. We will handle converting it to searchable vectors for the assistant. And then we have an agentic assistant that can take the input question, break it down into components, do the necessary searching to get the data, and then from there, address any other needs like graphing, and then produce the response in a more complete, more comprehensive manner. So that's enough talk from me for now. I'm going to get into the demo and actually show you how we build these assistants in IDS and interact with a few of them as well. So I'll start by logging in here. Pardon the network connection. There we go. Nice. All right. So I'm going to enter IDS now. Let's pick up where we left off. What I'm looking at is the IDS data catalog. So here I have imported a bunch of sources from a local Iris SQL database related to my demo phi schema. So if I were to open and look at one of these, you can see that I can introspect my structured SQL related data. I can look at primary keys, data types, field descriptions, so on and so forth. So my data catalog, I now have access to my relational data. But IDS can bring in more than that. I can also bring in unstructured data in the form of files. So I've created a document store here in IDS that contains a long list of files, 53 to be exact, and these are all investment research reports. How's the font size? Can everyone see? Thumbs up or thumbs down? Okay, I'll zoom in a little bit. All right, so these are publicly released articles from different banks. Just to open up a few, some of them are economic outlooks with a variety of different data in different formats, graphs, charts, tables. There's more here based on different sectors as well. For instance, there's some AI related articles as well. And what I want to touch on here is that these are all mixed media forms. So they have images, graphics, charts, data in all sorts of different modalities and representations. This is where I put my unstructured data here in IDS. So we have all this data here, but we still need it searchable by the assistants, right? We still need to put it somewhere where it exists as vectors, and we can run semantic search algorithms against it. That's where I configure my knowledge stores. So I have a list of out-of-the-box knowledge stores that I've configured here in IDS. These act as buckets where I can store my vectors to then make them searchable by the assistant. And you could say that we put all of the vectors on one table instead of grouping them, and that might be easier in some aspects, but having one big vector table with a bunch of different vectors from potentially irrelevant sources to what you're looking for will dilute the search, and it's also harder to enforce separation of concerns in case you have certain users who can only access certain data from that table. So I'll open up one of these knowledge stores just to show you how it's quickly configured. So you can enable or disable a knowledge store. We also implement role-based access control for knowledge stores. So if you're speaking with an assistant and you know a certain user class can't have their assistant access a certain knowledge store, they might have sensitive data that they're not allowed to see. You can limit that here. And then quickly on the description field, this is actually what we use for the supervisor. When it gets a question and it's looking at the potential knowledge stores to search, it'll read the description to determine which knowledge stores are relevant to the question. So this is a heuristic we apply to limit the amount of data that needs to be searched when input from the user comes in. All right, so these are the knowledge stores. These are the buckets of vectors that will be searched by the assistant. but we also need to set up an assistant. So here I have a list of assistants I've created. I'll open one just to show you how it's configured. There are a few different fields for this. Starting with vendor. Within the assistant, when we need to make an LLM call, when we have the vectors extracted from the database and our prompts and instructions and the user input, and it's time to do the thinking. It's time to make that LLM call to process all the information and generate a result. This is going to be the API we go to. So we're doing OpenAI on Azure here. Memory is just anything I want the assistant to remember for any question. I'll put that here. And of course, we also enforce role-based access control at the assistant level. If there are certain users who are trying to interact with an assistant and that assistant has a very specialized purpose or access to data that they shouldn't have, you can limit the user roles that have access to the assistant here. And what I'll finally show at the bottom is our list of agents. So you might notice that these agents correspond one-to-one with the knowledge stores I had enabled earlier. These agents exist because each agent is spun up to accompany a knowledge store to do the searching when we need information from that particular knowledge store. So these essentially represent both the capabilities that my assistant will be able to perform and the data that it can consult. Just to run through these quickly, for data catalog, I'll be able to ask about the shape and the schema of the different data sources I have available. For text to SQL, the assistant will be able to write and execute and show me results of queries ran against the database. For investment research reports, this means that the assistant will be able to consult the investment research reports data, the data from the files I uploaded earlier. And then there's also graphing. So the assistant will be able to graph data for me, and it will also be able to give me insights on any news articles that this IDS instance has loaded. I've now gone through how we've set up an assistant, as well as where we'll create and hold the vectors to be searched for by the assistant in the knowledge store. But right now, this data is still existing raw in IDS, right? It hasn't done that conversion yet to vectors in the knowledge store. We're still missing that verb. So that's where narratives come in. A narrative is just a manageable, runnable resource that takes the data in IDS and converts it to vectors in a knowledge store to make it available for semantic search. So I'll open up this SQL-based narrative here. For a SQL-based narrative, you just give it a table as well as a query to run against the table and a text template. And what it will do is run the query. For each row in the query, it will take the values of that row and inject it into the template. That template text is then vectorized and put in the vector database so that we have a natural language text representation of these rows in our SQL table. I'll also show you a document narrative as well for my investment research reports. So I'll point to a document store that I want to bring in documents from and convert to vectors. I'll also identify a file type I want to filter down to, PDF in this case. And then I'm also providing some different configurations based on parsing and chunking and summarization. Identifying the summarization prompt here in particular. What we could do is when we chunk a document and we convert those chunks into vectors, we could put those right into the vector database. But the thing is, when users ask questions, it's not really about specific verbatim, word-for-word text from certain passages in a document. Typically, it will be more general or vague references to the document as a whole. So what we do is once we break the document into chunks, we generate a summary of that document and contextualize each of the chunks with that summary. That way, when the user is asking those more general questions, we're more likely to get hits on the vector search by comparing not only to the exact passage from the document, but also the summary of the overall document. Now I'll actually start this narrative, and we will upload a file so we can have the assistant look into it later live. I'm going to upload this article here, which is a Bank of America write-up on the current state as well as the expansion of the sports industry. So I'll go over to my document store and do that. And in the meantime, I'll show you some conversations I've already had with our finance assistant. So I started off relatively easy, just relying on that data catalog functionality. And I did an exploratory question about that DemoFi schema that you saw me import in the catalog earlier. I wanted to know more about the tables and how they relate. So it gives me a quick description of the tables, as well as what each table represents. And from there, how they might be joined, how they relate to one another. Just learning a little bit about the schema here. And then I got right into text to SQL. So I started more easily, just having it rank regions by macro outlook. It gives me a nice little report consolidated here. And it also shows me the SQL that it ran against the database, as well as the result set that I got. I did another one here with just a max aggregation on indices with strongest 12-month returns. You can see it again provides me the query, as well as the results that were generated from the query, giving me the information I need. Then it got a bit more complicated. So I had to compute a custom metric that's a combination of falling inflation and rising PMI as part of its query. It's able to give me the results with the necessary deltas, as well as the strength score it computed and its interpretation. And then it also showed me the query it generated. Now, this is not something that a business user would likely be able to write, but this is a question a business user might ask. So you can see here the power demonstrated of being able to take natural language and then convert it to relational queries that we can run against our database. After that, there's also graphing. So this one is just CPI trend by region. There's more queries and results here. Then I also had to generate the graph, which you can find down here. Here's another one, comparing CapEx performance across tech-related industries. So this assistant is able to determine what industries and sectors I'm referring to when I say tech-related. It runs the query, and it gets me the results I need. And it formats it nicely with a report, followed by the graph I requested. What I've shown so far is just what I've talked about in regards to structured data. I've asked data catalog related questions about the relational data in my database. I've had it write SQL questions against that data, all operating against data with a strict schema, all from SQL tables. But I can do more than that. I can also tie in the data that comes from my documents. There's some examples here. I ask about the main findings in a Citibank's financial report and if they're consistent with data from our own house views table. So the assistant can search through these documents, find the relevant takeaways from the documents for me, even citing the exact page number that it was pulling the information from and the chunk it was looking at when it gave me the answer. From there, it can still query against our tables to find the relevant relational information that I'm asking for. From there, citing all of the references and providing me with the conclusion. Here I'm asking it to summarize demand data for the telecom services based on a few industry tables I have. So it provides me the queries it ran against the industry tables, as well as giving me a synopsis of the results. And then I have it compare that demand data to the findings in a Bank of America article on the rollout of 6G. And again, it will give me the findings in that article that are relevant to my question, citing the pages where it pulled the information from as well, showing me any SQL queries used, and then providing me with a nice synopsis. You might recognize this question from earlier. Are current geopolitical events reflected by our macroeconomic SQL data? So here, it runs another query to collect the GDP and CPI and other metrics that are necessary from the database based on regions. Then it also consults the news I have available, giving me the exact references to all of the articles that it's using to give me my answer. Synthesizing all of that information together for me to tell me what I should know. All right, so that document should be done uploading here. That's all set. Why don't we ask the assistant about something from that sports document I uploaded? We'll ask how much consumers legally wagered on sports in 2023. So according to research reports, how much did consumers legally wager on sports in 2023? So as I mentioned earlier, this will first go to the supervisor, and the supervisor will determine what knowledge stores are most relevant and should be searched in order to answer this question. It will identify the investment research reports knowledge store. From there, run the appropriate vector search against that knowledge store to retrieve the information that's needed. From there, it will run back through the supervisor, who will determine if the job is done, the information is required through our combinator, and finally output it to an answer, which of course is correct that, in fact, consumers did wager $100 billion on sports. This is a finance-based conversation I've had, but that is not the only industry that this applies to. You can do this just as easily for verticals like healthcare and supply chain. For instance, things like asking about encounter volume, augmenting that with different codes and descriptions, breaking down procedures by number of encounters, doing payment analysis based on paid claims by the payer, as well as graphing encounter volume, total billed versus allowed versus paid by payer, and lab result data too. It's all possible. You can do the same for supply chain. Things like the average time from order to ship, broken down by product type. Asking things like which types of inventory are held up in different warehouses. Carrier analysis based on the amount of deliveries that each carrier performed. Asking which product types are the most often to be returned. So the ability for IDS to unify all of this data and then having an agentic assistant that can ask questions about all of it and answer all of the aspects of the very multidimensional business queries in natural language that you might be submitting. It spans many industries and many use cases. Okay, so that concludes the demo. And I will wrap up with just a few key takeaways here. The first one being that Agentic AI and Agentic RAG is going to be better than a single LLM or simple RAG at answering complex questions. That's because this system can easily divide your user query into subtasks. With each agent performing a specified role in this system, it requires less context to do its job, can focus singularly on that job, and produce a higher quality result. In pairing this with Data Studio, you now have an incredibly robust RAG architecture where we can take structured, semi-structured, unstructured formats of data and all make it searchable via an assistant. So the era of manually aggregating and collecting and normalizing and standardizing your data is over. All you need to do, regardless of having a file system or a database or whatever data source you have, is just identify and load it into IDS. And from there, it can handle giving you AI-driven insights. So at the end of the day, just point IDS to your data, and the assistants will be able to give you complete and comprehensive answers to your multidimensional and real-world questions. That concludes the presentation. Thank you so much for your time. Okay, so we'll quickly transition into the Q&A portion here. I just wanted to point out all things IDS that are coming for this READY conference. So today, shortly after this, in fact, if you want to know more about IDS for supply chain in particular, that is the upcoming session today. Also tomorrow, we do more at the Tech Exchange with assistants. So if you want to see more interactions with assistants, different types of questions against different types of data, that will all take place there. And then on Thursday, if you want to know more about the IDS features and capabilities outside of assistants, what IDS can do as a data orchestration and warehousing platform, that's the session you'll want to attend on Thursday. I'll also note that my colleague Jayesh tonight at Demos and Drinks will have a setup there for assistant-based, for demoing the assistant and questions against it too. And then if you have business inquiries, if you think IDS can help your business, I've provided my executive Michael's contact information up here. He's also in attendance, so happy to talk after the presentation as well. But all that aside, I'm happy to take any questions or address any comments you might have. Yes, sir.
When you were showing the references that you got from the LLM, it was just by page number. That seems like a pretty wide range. I mean, is there a reason that you couldn't give like a paragraph or a sentence? Because, you know, in some documents, it takes a while to find, you know, what the reference is.
Yeah, I think you could potentially provide the exact passage or the chunk that it came from. That wouldn't be an issue. We just are relying on our functionality of already having the file stored and knowing the page number, so just pointing to the file in IDS, but that would certainly be possible.
Follow-on question too. Do you put an ID on every document, like a generated ID, like a UU ID?
Yeah, it's got a unique identifier, and in fact, if you upload it again, we'll assign a new identifier to determine if that is a brand new file or not as well. So yes. Mm-hmm. Yes, sir.
Is there a way to teach the system how to go out and harvest those documents that go into your knowledge store? Give it an arrow, you know, like you had financial documents from banks and financial institutions. If you were doing some other use case, you say, go find me all documents about the Apple new iMac or whatever. In other words, can you use the tool to have it go out to the world and bring things that are relevant into your knowledge?
Oh, like a web scraping connector kind of thing almost. That is potentially something we want to explore. What we can do now is you can sync up documents with different sorts of document storage structures you might already have in your ecosystem, like S3 buckets, or if you have SFTP servers. You can set that up to be synced automatically, and it will be converted to vectors and readily available. Exactly. Yes, exactly. Yep. Thank you. Yes. Michael, do you want to take that? All right. Thanks so much, everyone.